All right, we're still talking about slope. This is the 8th grade functions domain, 4th standard. We had a video on slope before, so I decided to make a part 2 because I neglected to mention the slopes of horizontal and vertical lines. And I'm going to dig a little deeper with slope, and it should help you with the packet I've already given you, which I will be extending the deadline to Tuesday. Okay? Let's do a recap. Again, this is part 2. We know slope explains the steepness of a line. So if we're thinking about that hill, remember that hill I talked about in class. If I'm looking from left to right and it looks like that line is traveling uphill, that's a positive slope. Still dealing with the hill metaphor. If I'm looking at a line and I look from left to right and it looks like we're traveling downhill, that's a negative slope. Well, today you're going to see what no slope looks like, and that kind of deals more when we start talking about horizontal and vertical slopes of horizontal and vertical lines, which we'll dive into next. Slope can also be defined as rise over run. Okay, the rise describes the changes in the rise. The run describes the changes in the x. Okay. And you know, just off your knowledge of cracking the math code, that the word change means subtraction. Okay? Hence the formula for slope. M equals y2 minus y1 over x2 minus x1. That's the change in the y's over the x's. In linear equations, and linear functions, slope uses the variable, and think about vocabulary, think about what variables are, of m. Okay? We know in a linear equation, when we see y equals mx plus b, which I exposed you to a couple days ago, the m is the slope and the b is the y-intercept. And if you don't remember what the intercepts are, you need to go back and look at Understanding Slope Part 1. And that's just a recap of what slope is. Okay? Now, let's talk about slopes of vertical and horizontal lines. Okay? Hopefully you copied this down. Okay? This is our B. Well, think about it. What does horizontal mean? Or what directions would a line be flowing in if it is horizontal? So let's draw a graph, Cartesian plane. Y'all know I'm not the best artist. Okay? Label your axes and your origin. And I hope you know how to label the Cartesian plane. So if you can't see my numbers, that still shouldn't explain why you can't draw this. Okay? If I draw horizontal line, and horizontal flows from left to right, hopefully you came up with that conclusion. That's a horizontal line, isn't it? Okay, so it's a linear equation. Horizontal goes through which axis? Well, here's the y-axis. Here's the x-axis. Where did your line hit? Well, Mr. Gray went through the y-axis. Where? At 2. So that means this equation is y equals 2. That's simple. Okay? So, horizontal lines left to right That's the direction. And they are expressed using y equals. Okay? And it goes through the y-axis. Okay? Vertical lines, excuse me, let me tell you about the slope. Vertical lines, horizontal lines have a zero slope. When you are using the equation for slope, when you see the zero in the numerator, it means it has a zero slope, and it should also indicate that it's a horizontal line, because horizontal and vertical lines have specific locations for the zero in the fraction. Okay? So make sure you're copying this down. If I was talking about vertical lines, which would be my number 2, vertical lines run north to south, which is top to bottom. They are expressed using an x equals. Okay? If I run a line like that, that's a vertical line, isn't it? Well, yes, Mr. Gray, because it goes from north to south. Where did it hit? At -4 on the x-axis. So that means the name of this line is x equals -4. Excuse me. It runs through the x-axis. Okay? It has an undefined slope. This occurs when you are using a slope equation to find slope and you have a zero in the bottom. So if you are finding slope using that equation and you come up with the fraction that has a zero in the denominator, you should associate it with vertical lines or undefined slope. Okay? And that kind of gives you more intel on slopes of vertical and horizontal lines. Okay? Let's look at the rise over run theory. If I draw Cartesian plane, and I draw a line